Hello students, welcome to the next lecture on the wave equation. This is the part 2 of examples related to the wave equation. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of Mathematics 2 where you can find the various lecture related to the content of the syllabus. Now what we have discussed in our part 1, that is a wave equation where u is called as the displacement, x and t are my position and the time. So what is the geometry of this? If you have the two fixed point O and A which are separated by distance L, and the equation of the motion of the wave is denoted by u at the position x and the time t. Now since the 2 points are my fix, it means the displacement at the point O and the displacement at the point A, which is separated by distance L at the time t. So since these 2 points are my fixed point, so it means there is no displacement at the point O and at the point A. Another thing, when the wave or the motion will start from the point O, what will be their initial velocity? What will be their initial displacement? So I denoted the initial displacement by fx, and gx is my initial velocity. Now based on the nature of the f and g, I discretize this lecture into the two category, type 1 and the type 2, where type 1 is consider all those functions whose fx or the gx, any one of them, is of the trigonometric form, and that lecture we already discussed in our last lecture, which is available at my YouTube channel. Now in this lecture we will see what will happen if your right hand side, that is whether fx or the gx is of the polynomial form. So that means in this lecture I will try to solve how you can solve the type 2 related wave equations. I hope you can subscribe my YouTube channel so that you can get the notification in advance. So what is the approach behind that? How you can solve that? I will explain you the 3-step rule. The step number 1 is you have to take the solution of the u, which is of the product of the function x and t, and then I can substitute the value of the u in this equation. What will happen? That is a partial derivative with respect to t. So that means x is a constant and double derivative, which is equal to c square and x double dash of t. And we can solve this equation and get the respective solution. Now once you will obtain the solution, look at all those conditions whose right hand side is my 0. In this particular case, we have the two cases where right hand side is 0. Then in step number 2 we will apply those conditions, and the last case we will apply all those conditions whose right hand side is my non-zero. So if you remember my previous lectures related to the type 1, the same approach I have explained to you. Now let's see how you can solve this with the help of the various examples. I hope you can like my video to support it. First of all, it is a wave equation and this is my polynomial, because every constant is my polynomial nature. So this is my type 2. Now once it's a wave equation, what is the equation form is? This is the wave equation. What is the length is? 0 to pi. So the length is my pi. How you can start that? I can substitute the value of the u, which is x into t, in this form where x is the function of the x and t is the function of the t only. So once I can substitute this value here, you will get x t double dash is equal to x dash of t. I can take x on the left hand side and t on the right hand side. Now since this is the function of the x only, while this is the function of the t only, and both are equal, only one case will happen when this value of lambda is my constant, because on the left hand side is the function of the x, this is the function of the t, and both are equal only when they are constant. Now I can derive the equation from this, that is x double dash over x is equal to lambda. That means x double dash minus lambda x is equal to 0. Similarly, I can take this pair and I can obtain this equation. Now since lambda is my constant, so what are the possible cases of this lambda? It may be positive, it may be 0, or it may be negative. So let's see, consider the case 1. When lambda is equal to 0, I can substitute the value of lambda in these 2 points. Your equation will be x double dash is 0 and t double dash 0. Can you find the solution of this equation? Now since this is the differential equation, can you write the auxiliary equation as we explain in our differential equation? That is m square is 0. M is my 0 and 0. So this means C1 plus C2 x. Similarly, for this case, what is my auxiliary equation? This is again m square is 0. So m is again 0 comma 0. So capital T will be my C3 plus C4 of t. Now once you know the value of the x and t, I can substitute the value of x and t. In this case, you will get the solution. Now once you know the solution, then I can apply the step number 2. Step number 2 is my all those conditions whose right hand side is my 0. This is the right hand side 0. This is the right hand side 0. This is the right hand side 0. So firstly I can apply the first two cases. Now u x comma t, this means x is equal to 0. So if I substitute here, it will be my C1 plus into C3 plus C4 of t is equal to 0. Now what will happen? Now clearly say either C1 will be 0 or this quantity will be 0. But this quantity can never be 0. Why? Because if C3 plus C4 t is 0, then what is the value of the u? U will be 0. That means we will get a trivial solution, but we always obtained a non-trivial solution. That means this number can never be 0. Hence, C1 will be 0. Now, I can apply the second condition. Now, since C1 is 0, this value will be 0. C2 pi C3 plus C4 of t is equal to 0. Again, this number can never be 0. Otherwise, u will be 0. Pi can never be 0. Therefore, C2 is my 0. Substitute the value of the C1 and C2 in this equation. You will get u is my 0, which is a trivial solution. Hence, our solution is discarded. Remember, we always need a non-trivial solution. Now look at the case second. When lambda is my positive, I can assume lambda is my k square because it is always positive. Clearly say lambda is non-zero, so k will be non-zero. Substitute the value of lambda in these two equations, we will get this expressions. Now can you find the value of x? What is the auxiliary equation corresponding to the capital X? M square minus k square 0. So m will be plus minus k. So it will be kx plus c2 e raised to power minus kx. Similarly, can you find the auxiliary equation corresponding to the capital T? It is m square minus k square 0. Again you will get m is plus minus k. So I can say e raised to power plus kt, e raised to power minus kt. Substitute the value of the x and t in my u. So therefore, this is my solution. Now once you know the solution, I can apply all those conditions whose right hand side is my 0. So let's see firstly this case. That means x is my 0. When you substitute x is 0, this is e raised to power 0, 1. You will get this expression. Clearly say this term can never be 0 because if this is 0, then complete u will be 0. Therefore, C1 plus C2 is my 0. Now look at this expression. That means x is equal to pi. So if I substitute x is pi, e raised to power k pi plus C2 e raised to power minus k pi into C3 e raised to power kt plus C4 e raised to power minus kt. Again, this number can never be 0 because otherwise u will be 0. This implies C1 e raised to power k pi this 0. Now from this case, I can find the value of the C2 is my minus C1. I can substitute this value here. C1 will be common. K pi minus of k pi is 0. So this implies C1 will be 0 because this number is always a non-zero. So once C1 is 0, I can substitute here. Therefore, C2 is also 0. Once C1 and C2 is 0, I can substitute here. You will get again as a trivial solution. Therefore, this solution is also discarded. Now, look at the third case. When lambda is my negative, that means I can take lambda is minus k square. Again, I can substitute the value of lambda in these two equations. Now, again you can define the auxiliary equation. What is the auxiliary equation? Is m square plus k square is equal to 0. That means m is my plus minus k iota. So once it's a complex number, you know you have to write the equation in the form of sine and cosine, C2 sine of kx. Similarly, you can define the auxiliary equation for this and you can get the value of capital T. This substitute this value of the x and t in this case. Now once you know the solution, again you will get the solution. So your target is to find these unknown parameters. Again because once you know the solution, I can apply all those conditions whose right hand side is my 0. Look at that, C1, this means x is equal to 0. So I can substitute here, cos 0 is 1, sine 0 is a 0. So this number is C3 cos kt plus C4 sine kt is 0. Again, either this will be 0 or this will be 0. But again, this number can never be 0, because if this number will be 0, then u is again 0. Hence, C1 will be 0. Now, I can substitute here. That means, this means x is equal to pi. I can substitute C1 is 0. So, this number becomes C2 sine k pi into C3 cos kt plus C4 sine kt is equal to 0. Now again you have this 0. Can C2 be the 0? Or either this 0 or this 0. Again this number can never be 0, otherwise u will be 0. C2 again can never be 0, because if C2 will be 0, C1 is already my 0. So that means u is my 0. So C2 can never be 0. This can never be 0. This implies sine k pi will be 0. What does it mean? The k pi will be, when the sine term will be 0, that is n pi. So can you find the value of the k? K will be my n, where n start from the 0, 1, 2 and so on. Now for the third case, you need the partial derivative. So let me firstly calculate del u by del t. So because this is the partial with respect to t, this is my constant, I can written as such, and you can derivative this with respect to time. Now you can substitute this value. That means, what does it mean? That means t is equal to 0. So since C1 is my 0, fine. So this becomes C2 sine kx. When t is equal to 0, sine of 0 is 0. C4 k cos 0 is my 1. Fine. So that means C2 C4 k sine kx. Again, sine kx can never be 0, because if sine kx will be 0, then this quantity will be 0 and C1 is already 0. So that means this number can never be 0. C2 can never be 0, because if C2 is 0, then C1 is already 0, complete 0. K, because we consider the case lambda is less than 0 and lambda is my minus k square, definitely k can never be 0. Hence, C4 will be my 0 in this case. Now I can substitute C1, K and C4 in this equation. This will be 0, C4 will be 0. I can substitute the value of the K as n, and C2, C3 sine nx and cos n into t. So this is another constant I taken as a dn. Now since it consists of more than one value, I can apply the principle of superposition. Now lastly, I can apply all those conditions whose right hand side is my non-zero. So since right hand side is my non-zero is only this, that means t is equal to 0. The left hand side is p, cos 0 is my 1, this. Now how you can find the value of dn? So clearly say which is a Fourier half range sine series. So once it's a half range sine series, your target is to find the dn 0 to L fx sine n pi x over L. So what is the value of the L? You can see from here. This is the value of L. So it's a 2 over pi, 0 to pi. What is the fx? What is the fx? Fx is my this. L is my pi. So this pi and this pi cancel out, is a nx. Now you can integrate them. 2 p is a constant which is outside. What is the integration of the sine? it is my minus cos nx divided by n from 0 to pi. Now I can substitute the upper limit. What is the upper limit is cos n pi. Cos n pi is minus 1 raised to power n. When you substitute 0, minus minus plus 1. Now finally, you can substitute value of this dn in this case. You will get the right answer of this problem. Now look at this another question. A tight stretch string is with a fixed point. So string that always behave like a wave equation. So you can start like a wave equation. What is the length is? L. Fine. The end points are my fixed. So that means 0 comma t is my 0, and at the point A whose length is my L. This is given to me. Is initially in the equilibrium position. That means there is no displacement. So that means initially, what is the meaning of the initially? That is the time is 0. And if it is set with the velocity, that means del u upon del t at the initial time 0 is given as kx of L minus x. So that is given to you according to the statement. Now once you know this is the equation, we can start with again u is equal to x into t. I can substitute this value in this equation. You will get x t double dash, which is c square x double dash of t. I can take x on one side and t double dash c square of t on the other side. Now both are my equality. One is a function of the x, second is a function of the t. I can say lambda, and lambda must be my constant. Now again you have derived these equations. Again you have the three cases when lambda is equal to 0, lambda is greater than 0 or less than 0. So let's see, first lambda is equal to 0. I can substitute the value of lambda here. You will get x double dash 0, x t double dash 0. Again you can write the auxiliary equation. M square is 0. So that means 0 and 0, c1 plus c2x. Similarly for the capital T, you can define like this method. Substitute the value of the x and t in this equation. Remember, in each question you have to proceed in a similar manner. Now once you know this is the solution, once you get the solution, I can apply the step number 2. All those terms whose right hand side is my 0. So let's see firstly this quantity. When x is equal to 0, so it's a c1, c3 plus c4 of t. Again you can see this quantity can never be 0, otherwise u will be 0. Therefore c1 is my 0. When you have the L, so since c1 is my 0, so it is c2L c3 plus c4 of t. Again this number can never be 0, therefore c2 is my 0. Substitute both the value of c1 and c2, you will get as a trivial solution, hence solution is discovered. Look at the second case when lambda is my greater than 0. Then in the last example I have taken lambda is equal to k square. In this example I have taken lambda is alpha square. Why? Because you can see k is already present in this statement. Fine. K is already present in the statement. So I have to use some another symbol. You may use lambda is equal to b square. You may use lambda is equal to a square. You may use lambda is equal to capital A square as per your convenience. Now once I can take lambda is equal to a square, I can substitute the value of lambda in these 2 points and then find the equations. Auxiliary equation is m square. M will be plus minus alpha. So c1 e raised to power alpha x, c2 e raised to power minus alpha x. Now I can substitute the value of the x and t in my given equation. You will get this solution. Once you got this solution, again I apply those conditions whose right hand side is my 0. So if I apply this condition, when x is equal to 0, c1 plus c2 into this value. Clearly say this number can never be 0, therefore c1 plus c2 is 0. Similarly, I can apply for the pi. This quantity we all know this can never be 0, therefore this number will be 0. I can solve the equation number 1, I can solve this equation number 1 and equation number 2 you can go as C1 and C2 both as a 0. Therefore, u will be my 0. So therefore, this case is also discarded. Look at the third case. Again, I can take lambda is negative, so lambda is alpha square. I can substitute here. You can obtain the auxiliary equation, m square plus alpha square 0. M will be plus minus alpha iota. So that means you have to write in this form. Substitute this equation in this manner. Now again, you obtain the solution. So I can apply all those conditions whose right hand side is my 0. Fine. So let's see first case. X is equal to 0. I can apply this case. So it's a C1. X0 is a 0. So C3 cos alpha Ct plus C4 sin alpha Ct. Clearly say this number can never be 0 because otherwise u will be 0. So what does it mean? C1 will be 0. Fine. Similarly, you can apply this case at x is equal to L. So since C1 is 0, it will be cancelled out. C2 sin alpha L into this value. Clearly say this number can never be 0. C2 can never be 0 because if C2 is 0, C1 is already 0. So therefore u will be 0. So this implies sin alpha L will be 0. So if sin alpha L will be 0, alpha L will be my n pi. So can you find the value of the alpha? It is n pi over L, where n start from the 0, 1, 2, so on. Look at the last case. That means t is equal to 0. I can substitute t is equal to 0. So this value will be 0. C1 is my 0 because I already obtained. So this is C2 sin alpha x. C3 cos 0 is my 1. Now clearly say C2 again can never be 0, otherwise u will be 0. Sin of alpha x can never be 0 because if this quantity will be 0, this whole quantity 0, C1 is already 0. So this implies C3 will be 0. Substitute the value of C1, alpha and C3 in this equation. So this is 0, C3 will be 0. Then if you multiply them, C2, C4, sin alpha is n pi over Lx, cos, again this is sin n pi. So I consider this is a constant as another term dn. Now it consists of more than one value of the n. I can apply the principle of superposition. Now because it start from the 0, n start from the 0, or you can skip the 0. Why? Because you can see what is the value of the n 0. If you substitute here, it's a 0. So that's why there is no need to write as a 0. Now look at this value. This is a non-zero term. Fine. So for that you need a del u by del t. So in order to apply this term, we firstly calculate the partial derivative with respect to time. So sine will be the cosine. Coefficient of this is here. Now apply this case. Time is 0. When you substitute t is equal to 0, the left hand side is kx L minus x. Cos 0, it will be my 1. So your expression will be. Now again it's a half range sine series. So again your target is to find the half range sine series. The coefficient of the sine is my dn n pi c upon L. What is the fx? Fx is my this number. So I can substitute this. L will be cancelled out. dn will be 2 over n pi c, 0 to L. Fx is my k. K is outside, Lx minus x square. Now you can integrate them. How you can integrate? You can integrate by parts, or as I told you in my last lectures, you have to find the derivative of the first part, that is L minus 2x, then minus 2 and 0, and integration of this part, minus sine of whole square, and then you can plus, minus, plus, so on. So once you can go there, you will get this expression. Now substitute the upper limit. When you substitute L, it's a L square minus L square, 0. It is sine n pi, because x is L, sine n pi is 0. Cos n pi, so it's a minus 2 L cube over n cube pi cube. Cos n pi is minus 1 raised power n. When you substitute 0, it's my 0. Sine 0 is a 0. Cos 0 is 1, so it's a minus minus plus 2l cube n cube pi cube. Fine. Now you can take as a 2l cube n cube pi cube as a common. You will get this expression. Now finally you can substitute the value of this dn. This is the value of dn in my this case. You will get the required solution of the problem. Okay, look at this another one. Find the deflection of the string. So string is always look like a wave equation. Fine. The length is my pi and c is my 1. So that's why it's my 1. End points are my fix. What does it mean? 0 comma t is my 0. What is the length of this is pi. So pi comma t is my 0. With the 0 initial velocity. This is my velocity. Initial means time is 0 here. And initial deflection. Deflection means that is a u. X comma 0 is given as kx pi square minus x square. So that things are given to you. Now you can start from the u is x into t again. Substitute this value in my this case. You will get the same equation. Again, you have the three cases. When lambda is equal to 0, you can substitute here and you will get the value of the x and the t. Now once you got this solution, I can apply all those equations whose right hand side is my 0. So that's a similar task as I explained in the previous two examples. Case second, when lambda is my greater than 0, again I'm not considered as a k because k is already given to you in the statement. Again you can write as a solution capital X and the capital T. And you can see this is a similar case of the previous one. You can substitute x is 0, you will get, because this quantity can never be 0. When you substitute pi, again you will see this quantity can never be 0, otherwise u will be 0. Solving the equation number 1 and equation number 2, you will get a trivial solution. Let's again discuss the case number 3. When lambda is my negative, then you will get the solution in this form. Now once you got the solution, I can apply all those conditions whose right hand side is my 0. That means these three cases. Let's solve this one again. X is equal to 0. Again if I substitute here, it is my C1 plus C2 is 0. So C3 cos alpha t plus C4 sin alpha t. Again it is clearly said this number can never be 0, otherwise u will be 0. Therefore C1 is my 0. U of pi comma t. So C1 is my 0. I can substitute this value. You will get this expression. This number can never be 0. C2 can never be 0 again, because if C2 is my 0, C1 is already 0, so whole quantity will be 0. That implies sin alpha pi will be 0. So that implies alpha pi will be my n pi. Hence alpha is my n, where n start from the 0, 1, 2, so. In order to find this, so we need a del u by del t firstly. So you can find the u with respect to time. You will get this expression. Now you can substitute t is equal to 0. C1 is already 0. So it becomes C2 sin alpha x. When t is equal to 0, sin 0 will be 0. And it is my alpha times C4. Fine. So I can say C2 C4 alpha sin alpha x. Or alpha is a non-zero. C2 again can never be 0. Sin alpha x again can never be 0, because if sin alpha x will be 0, C1 is already 0, the whole quantity will be 0. Hence C4 is 0. I can substitute C1 alpha and C4 in this case. This will be 0, this will be 0, and if you multiply them, it is a C2 C3, alpha will be my n, that is a sine and cosine. So this quantity I called as another constant dn. Now since it consists of more than one value, again I can apply the principle of superposition. Again you can see what is the value of the n0? If you substitute here, sine 0 will be 0. So either you can start from the 0 or you can write as a 1. That's the same meaning for this case. Now look at this case, whose right hand side is my non-zero. I can substitute t is equal to 0 in this expression. So the left hand side will be my kx pi and cos 0 will be my 1. Again, this is the half range sine series. We can find what is the value of the L, because my limit is 0 to x 2 pi. So this is my L. So I can say 2 upon L, 0 to this is my fx. K is outside, 2k upon pi. X I can multiply them. Now again, you can solve this integration by my previously methods. So it's you can derivative them, 3x square minus 6x minus 6 and 0. And on this side, you have to integrate them. So it's a minus cos nx over n minus sine nx over n square plus cos nx over n cube plus sine nx over n4. So once you multiply them with the positive sign, with the negative sign, with the positive sign, with the negative sign. So you can multiply them, you will get this term. You can see pi square x minus x cube minus cos nx divided by n. Second quantity is minus minus, that's a minus pi square 3x, this quantity. Now you can substitute the upper limit, 2k upon pi. When you substitute pi, pi cube minus pi cube 0, sine n pi 0, cos n pi, so it is minus 6 pi cos n pi this over n cube, sine n pi is 0. When you substitute 0, it's a 0, sine 0 will be 0, cos 0 will be 1, but this x is a 0, sine 0 will be 0. So you have the only this quantity. Now you can multiply them, it's a minus 12k minus 1 raised power n over. I can substitute this value at this expression, you will get the right answer. I hope you can like my video if you feel it is very useful for you. You can share this video with your friends so that they can also learn in a simple manner. Okay, a string is also a wave which is a distance of 1 unit apart. Now, which is stretched and fastened at the 2 points. That means they have the fixed end points. That's the meaning of the same thing. So what does it implies? u0 comma t will be 0. The length is my 1. So 1 comma t will be my 0. And it released from the rest. Once it released from the rest, it means the initial velocity will be 0. Fine. And the initial deflection, that means ux comma 0 is given to by this quantity. Fine. This is my initial velocity. Again, the similar manner, you can start from the u and you can consider all those cases, case 1, case 2 and case 3, you will get this expression. Now remember that when you consider the lambda is greater than 0, you can take lambda is equal to k square because there is no k involved in that. When lambda is less than 0, you can take lambda is equal to minus k square, again because no k square involved. Now once you got this solution, I can apply all those conditions whose right hand side is my 0. So again, this is a similar case. When you substitute x is my 0, you will get again c1 is 0 because this number can never be 0. Similarly, when I take x is equal to 1, so since c1 is 0, so c2 sine of k, c3 cos kct plus c4 sine kct is 0. Clearly say this number can never be 0, c2 can never be 0, hence sine k will be 0. So can you find the value of the k? K will be my n pi. The last case, you have to find the del u by del t firstly. So if you take the derivative, you will get this form. Now substitute t is equal to 0. This value will be 0. c1 is my 0. Cos 0 is my 1. So this number will be c2, c4. K can never be 0. C can never be 0. So this number C2 can never be 0, this can never be 0, C4 will be my 0. Substitute the value of these three expression in my this 0, this 0. So C2 and C3 I call as another constant. Again you have the different value of the n, I can apply the principle of superposition. Now again I can apply the non-zero condition, that is I can apply here at t is equal to 0. The left hand side is my this, I call as fx. So the left hand side is my fx. This value cos 0 is my 1, which is again a half range series. So you can start from this again. So since L is my 1, so it's a 2 upon L n pi. Remember what is the dn is? Always 2 over n, 0 to L fx sine n pi over L into x. So in this particular example, L is my 1 because the wave equation, the distance between the O and A is my 1. Now you can substitute this value of fx. I can break this into the two parts, 0 to half, half to 1. You can solve this either by integration by parts or by using my simple this approach. You can take the derivative until 0 and integration on the right hand side of this side, sine n pi x divided by n square pi square. Now you can multiply them with the positive sign, multiply with the negative sign. So it's a minus x cos n pi x by n pi and minus plus sine n pi x divided by n square pi square. Similarly for this case. Now you can substitute the limits. When you substitute x is half, you will get this expression. Now clearly say this value and this value will be cancelled out. It is my 2 times. So it's a 4 over n square pi square sine n pi by 2. Substitute this value of the dn in my principle of super, that's this value. Substitute this value of the dn in my this case, you will get the required solution. I hope you can like and comment on my video as well. We will see the next lecture on the heat equation. Again with the help, similar manner you can learn many lectures with the easiest manner. I hope you can share my video with your friends. Best of luck students. Happy learning.